Questions like this, guys, which combine the sine and the cosine rule, actually come up quite often in exams, and they're worth a lot of marks. Now, I do want to make it clear, when going through this, I'm going to assume that you're really confident with both the sine rule and the cosine rule, so if you're not, make sure you watch my previous videos first. Let's have a look then. This one says, given the following diagram, calculate the length of AD. Now, AD is going to be the side length, which is between the point A and the point D. We can see that it's going to be this side length here on the left-hand side of our larger triangle. However, we don't actually have that much information about this left-hand triangle at the moment. We know that this side length down here is 8, but we don't actually have any other information to help us. That is where, guys, the other triangle is going to come in, and we are going to be using the sine rule to work out the common side length between these two left and right-hand triangles. That is going to be this side length here, connecting point B and point D. How do we know we can use the sine rule for this, guys? We know because we're going to be working with two pairs of opposites. We have this angle 50 and this opposite side length of 6, and then we have this angle 48, and we want to work out this opposite side length, which is side DB. Now that we know we're going to be using the sine rule, guys, we need to decide whether we're going to be using the one that has the side lengths on the top or the angles on the top. Because we want to work out a side length here, we're going to have the side lengths on the top of our fractions. Writing out the sine rule then, we're going to have that A over sine of A is equal to B over sine of B. And we have to remember, guys, that our lowercase letters are our side lengths and our uppercase letters are our angles. Next step, we're going to label our two pairs of opposites. We're going to label this side length A, the one that we want to work out, and the opposite angle is going to be uppercase A. And then we're going to have lowercase b for that side of 6 and uppercase B for the angle. Next step, guys, we're going to substitute in and rearrange for A. So, subbing in, we're going to have A over sine of big A. Big A is 48, so we have A over sine 48. That is going to be equal to lowercase b, which is 6, over sine of uppercase B, which is 50. Next step, guys, we're going to rearrange this to make A the subject. In order to do that, we are actually going to multiply both sides of our equation by sine 48. Now, just to save a little bit of room on the screen, I'm going to do it like this. So I'm going to times this side by sine 48. And then I'm just going to rub out the over sine 48 on the left-hand side. That is going to be the effect of multiplying by sine 48 there. Next step, guys, we can bring this into our calculator. Let me do that now. We're going to have 6 over, and then we have sine of 50, and then we have times by sine of 48. Close those brackets. What are we going to get? We're going to get 5.82, I should say, to 2 decimal places. So we can say that the value of A is equal to 5.82. Where are we going to go from there, guys? We're going to write that onto our diagram. So we can say that this side length is 5.82. And now I'm just going to shift into my green pen to move on to the next part of this question. We see now that we want to work out this length of AD. So that's going to be this side length on the left. And we currently have two side lengths. We have the 8 centimeters and the 5.82. In order to use the cosine rule to work out a side length, though, what else do we need? We also need the angle in between the two sides that we know. So we need this angle here, angle ABD. How are we going to find that, guys? Any ideas? We are actually going to firstly find this angle here, angle DBC, using the fact that the angles in a triangle add up to 180, and then we can subtract that from 180 because these two angles on a straight line are also going to add up to 180. So doing that now then, we're going to do 50 plus 48, 50 plus 48, that is going to be 98, and then we're going to do 180, subtract 98, and that, guys, is going to be 82. So we know that this angle here is 82, meaning that this angle on the left is going to have to be 98, because 98 plus 82 is 180. Now, guys, that we've done all of that, we can do our final step, which is going to be using the cosine rule. What's the cosine rule formula, guys? You should know this if you're watching this video. It is a squared equals b squared plus c squared minus 2bc cos A, where uppercase A is the angle that we know, lowercase b and c are the two side lengths either side of that angle, and lowercase a is the side length opposite the angle that we know. Final step, guys, let's substitute in and rearrange to solve for A. We're going to have that a squared is equal to 8 squared plus 5.82 squared minus 2 times by 8 times by 5.82 times by cos of our angle, so cos of 98. To rearrange this for a, guys, we currently have a squared as a subject. We're going to square root both sides of our equation. Again, just to save a little bit of room, I'm going to write this on the same line of working out. So we're going to square root that left-hand side, we get a. Square rooting the right-hand side, we're going to have the square root of all of that. Final step, guys, let me type this into my calculator and see what we get. We're going to have the square root of 8 squared plus 5.82 squared minus 2 times by 8 times by 5.82 times by cos of 98. Close those brackets, calculate it. Guys, as our answer, we are going to get that a is equal to 10.53, and our units, guys, are going to be centimeters because all of our side lengths are currently in centimeters. Guys, that was a mammoth of a question. If you're watching on the vertical video, my head kind of got in the way a bit there. Hopefully that was clear enough. We had to use the sine rule first of all, and then we finished off by using the cosine rule.